Hello students, welcome back to this session. Let's start today's discussion with irrational number. I'm pretty sure that most of you guys already are aware of what irrational numbers are, but then just a introduction to irrational numbers will be very good. So now the idea is that irrational numbers are definitely real numbers, but the only thing that you need to remember or understand is that they cannot be expressed in the form p by q. Now, obviously, because they are irrational, that means they show some irrational property, which is in the English language context, irrational means makes no sense. And if you typically look at the irrational numbers, for example, let's take the common root over 2, which is called the Pythagoras constant. We discussed about this in the last session. If you see, the value of root over 2 is 1.414, and the numbers, the dot numbers keep on repeating till infinity, and these numbers keep on changing. So there is no one fixed pattern through which we can predict the number. Similarly, for another number which we just mentioned, pi, which is also an irrational number, which is definitely not equal to 22/7, as I have already said in the last session. A very interesting idea that you should keep with yourself is that decimal expansion of the irrational numbers neither terminate nor is periodic. As the name suggests, they are irrational, they make no sense. Their decimal expansion goes on till infinity with numbers coming in, popping here and there. So there is no one fixed pattern, and because it does not have a fixed pattern, it cannot be expressed in the p by q form mathematically. Now I would ask you to pay attention, because now we will try and understand how to distinguish between rational and irrational numbers. So the first question in front of you, check if root over 5 raised to the power 100 is rational or irrational. Now at this point you can pause the video, try to think about it. So let me give you the understanding behind this. In the chapters of exponents, we will learn that the square root function is nothing but a power of half. Okay, the power can also be called an index. So an index of half or a power of half is the same thing, but this is equivalent to square root of 5. There is already a 100 there. So this effectively boils down to 5 raised to the power 50. Now 5 raised to the power 50 is a rational number, of course. So what is it that we understand from this question? We understand that simply by looking at a number and a square root over it, or any of those things, is not sufficient enough to predict whether the number is rational or irrational. We need to do some logic. We need to put in some logic behind that in order to predict whether the numbers are rational or irrational. Now, one more question let me give you. Think about this. Root over 5 raised to the power 100 plus 1 by root over 5 raised to the power 100. Now, I'm giving you like 30 seconds to think on it. You can pause the video and check whether this is rational or irrational. I hope you have given the answer. You have the answer ready. And the answer is, we have just now calculated that root over 5 raised to the power 100 is rational. and rational 1 by a rational number, so 1 by p by q is as good as q by p, which is again a rational number. So this is also a rational number. So the sum of two rational numbers is a rational number. So by logic we could have understood that this expression root over 5 raised to the power 100 plus 1 by root over 5 raised to the power 100 is also rational. You didn't really need to do any calculation. You can calculate also, but it is not always mandatory to convert the numbers to the p by q form and then predict whether it is rational or not. You can directly do it. We have already talked about pi. Pi is a very interesting number, so I'm not gonna be continuing with pi. Let us now talk about integers. I have already given you the idea of integers in the last session. Here I am just going to be elaborating the idea. So integers are integral numbers, okay? Integral numbers which don't have a decimal part. This is the, you can say colloquially, or a very loose definition of integers. Numbers which don't have a decimal part, let's say -2, -100, the same examples, right? Minus, let's say 10, plus 10, 20, 0, etc. Now please understand, when I say integers, I should again tell you that they consist of the negative integers, or the negative numbers I should say, positive numbers, and always remember that 0 is neither positive nor negative. I have already said this, but I am again reiterating it as an idea, because questions can be framed to trick you into considering 0 as one of the integers. When we say non-negative integers, because you will keep on saying non-negative integers, this is a term which is used typically for 0 and positive integers, okay? Please understand, when 0 is non-negative, 0 is non-positive, so non-negative integer sets will include 0 as well as the positive integers. This is something that you just need to understand. One more thing, if they specifically say that calculate positive integers or positive integral values, then you will have to actually exclude 0, because 0 is neither positive nor negative, okay? With that being said, let us now go to the next part, odd and even numbers. We all know what odd numbers are. We are all aware of the odd numbers and the even numbers, but it is very easy to remember an odd number which is not a multiple of 2. Or I should say that every integer of the form 2n is an even integer, where n belongs to integers, okay? And when I say integer, it includes positive, negative as well as 0. Please remember, this is something that you should pay attention. 0 is an even number, or even integer also you can say, okay? 0 is an even integer. Keep this thing in mind. Now what about odd integers? So definitely odd integers can be expressed as, odd numbers or odd integers can be expressed as 2n plus 1. At the same time, you can express this as 2n minus 1. Now at this point I must tell you that this n is also all the integers, okay? So n basically belongs to all the integers. Now remember, you can substitute for 0, but then when you substitute n equals to 0, the number will either be 1 or minus 1. So in that case, 0 will not be a odd number. 0 will be even number only. Okay. This is a interesting idea. I am just expecting you to just keep these things in mind. They are never going to be tested in an exam condition, but here the knowledge of these things will be helpful. Now a very important topic, let's understand this in greater detail. This is, I call this the odd even parity. Now what exactly is odd even parity? Let's try and understand. So let E will represent even numbers and O will represent odd numbers. Okay. Now I am trying to understand the operations of addition or subtraction of odd numbers and even number to predict what is the outcome. So let us try and understand something. Let us take the case of even numbers. So even plus even, if you add, you will typically get even number. If you add one more even, you will still get an even number. If you add one more, or for that matter two more even numbers, the resultant number will be an even number. And the same is true if you subtract. For example, from an even number, if you subtract an even number or two even number for that matter, three even number, even four even numbers, whatever you do, addition or subtraction, the number will be even number. This is so addition of even numbers, or the role of even numbers in addition and subtraction is typically irrelevant. So let me use different color. So even numbers are irrelevant in the order of operation. Now one more thing, the idea that you need to understand, on you need to pick now, is that what about if I add two odd numbers? If you add two odd numbers, you'll get a even number. Please pay attention. If you add three odd numbers, you'll get a odd number. If you add four odd numbers, you get a even number. At this point, please pay attention because this is important. The idea with odd numbers and even numbers will typically revolve around just the odd numbers, because the numbers after the addition or the subtraction, the type of number that you get only depends on odd numbers. So odds are only relevant. I should have written odds only are relevant, but I'm hoping that you will understand this much. Okay. Now, so then what is this thing? Odd plus odd is equal to even, odd is equal to odd. If you pay attention, the number of odds, if odd, the summation or the subtraction will be odd. If the number of odds in the summation or the subtraction is even, the summation or the subtraction of the number that you will get is going to be even. So it is dependent on the number of odds and not just the odds. How many odds are present? So suppose I give you an idea. So suppose I give you a number like this: even plus odd minus even plus odd. What is going to be the resultant nature of the number? Now you can pretty easily say in one go that the number is going to be odd. And how is that so? Because just now we had mentioned that these numbers are irrelevant in determining the nature of the number at the end of the calculation. The only thing that I need to pay attention is the number of odds. Oh, so there are 4 odds, right? So I made a mistake. I didn't pay attention. This is going to be even because there are 4 odd numbers. Because there are four odd numbers, this is a even number. Let's check. So let's say 2, 1. Let's give 1 only, and 2. Let's add these. Give the signs as well. Minus, let's say 4 plus 3 plus, let's say odd, right? So I'm gonna give 5. Okay. Let's do the BODMAS way. So this is going to be 8, 8, 9, 10, 12. 12 minus 2 is 10, minus 4 is 6. The minus 2 minus 4 is 6. And 6 is an even number. You can actually check these things by putting as many numbers as you like, but the idea is this only. And there are very interesting puzzles that one can design. There is actually a puzzle in the book by the name George Summer. I will upload that puzzle in the assignments. If you know this idea, the puzzle is not that difficult. If you don't know this idea, definitely you'll have to do some hit and trial. Now, one more idea that I should give you, which is the exponents. So odd raised to the power even is odd. Remember this as a property. Odd raised to the power even is odd. Let's see. 3 raised to the power 2, that is 3 square, is 9. Satisfies. Even raised to the power odd is even. Needless to say, even to the power even is always going to be an even only. So let's see. 2 raised to the power 3. We know this is going to be 8. 2 into 4 into 2, that is 8. You can write it like this. 2 into 2 into 2. That gives me 8, which is an even number. So the point that I'm again trying to mention or highlight is that in any of these steps, if you're uncertain about any calculation or any idea, you can just plug in the numbers and check. But pretty much this is the thing that one needed to understand. Odd even parity is a very important area, and questions have been asked from this area of odd even parity. So this is it for this session. Thank you.